Hey scholars, so today we are going to be continuing to work on finding the volume of a cube. But in this case, we're actually going to be working on sort of some shortcuts. So up until now, we've been doing a lot of, counting the cubes to figure out how many cubes there are and knowing that the amount of cubes equals the total volume, right? Um, Sometimes this gets a little bit tricky when we can't necessarily see all of the cubes and we can infer that certain cubes are there based on physics. So for example, if I look at this and I know, that there's a cube here, there has to be a cube under it because it wouldn't be able to, float on its own. There has to be something below it to build the structure. So what I want to do today, what I want to do with you is look at some patterns that we see to help us find the volume of a cube. The way we're going to do that is we are going to start by counting the cubes and to find the volume of this first structure. Let's call this one structure A, let's call this one B, and let's call this one C. All right, so if we look at structure A, we can count the cubes. We could say there's 1, 2, 3, 4, and the reason I'm actually going to put the 4 like that is to remember sometimes we get confused and we forget that this side and this side are actually the same cube. Let me go here, 5, and 5, remember, if I'm thinking about it, would be like, if I break this and I continue the lines, we would have 5 would be this cube as well, 6, make that 6 bigger, 7, and 8. So I notice that we have a volume of 8, therefore we have 8 cubes. So when volume is going to be 8 for structure A. Now if I look at structure B, and also I just want to point out really quickly here, for back to A going across, the length is 4, right? Let me actually put this a little bit up so we don't get it confused with B. The width is 2, and the height is 1, right? If we look at structure B, I want you to notice that the bottom layer is actually, or let's just even start with the top layer, this layer here is identical to A, right? If I just look at one layer, just this one layer, I know that that layer is the same as A, right? This top layer, only the top layer, has 8 cubes because it looks just like A, and we already figured out A's volume. 1, 2, 3, 4, 5, 6, 7, 8. But the thing is there's a second layer here. So here, this bottom layer, what volume do you think just the bottom layer would have? I want you to take a minute and think about that. So hopefully you thought that it might be 8, and that's awesome if you did. If not, ask yourself, why is it 8? Well, it's 8 because I know based on physics, that based on like science, that this top layer can't stay up on its own unless it has something below it. So since there's 8 up here, even though I can only see 1, 2, 3, 4, 5 down here, I know that there's one holding up this brick, and this brick. So if there's 8 up here, there's going to be 8 down here. 8 plus 8 is going to be 16. So this one's volume is going to be 16. Now if we look at C, I want you to take a minute and I want you to write down a prediction. What do you think the volume of C would be? And I want you to again notice that here we've got, it's not exactly the same as A and B. It's a little bit different. We have, let's just look at this top layer again, all right? So here we have, and what I'm going to do is I am actually going to draw out, I'm going to continue these lines out, right? So it looks a little bit more like we can count each and every cube. And you'll notice that the way I did that is I just continued each line, right? I didn't create any new lines, I just continued each line across. So if we count the top layer, we would have 1, 2, 3, 4, 5. Here would be 6, 7, 8, 9, and 10. So just the top layer is 10. And since this is a cube, and since these can't just hang out on their own, they must have things below them. If this top layer is 10, then this second layer is also going to be 10. And this layer is going to be 10. And this bottom layer, therefore, will also be 10. So what do I have here? Well, remember, volume is the amount we can fit in. So if I have 10 here, 10 here, 10 here, 10 here, and I have 40 in all, so the volume of C is going to be 40, right? So that's one way we can do it, is we can sort of look at, well, we can notice patterns. If this is 10, then this will be 10, this will be 10, this will be 10. And I can kind of quickly calculate the volume that way rather than counting each individual cube, which also might get me a little confused, especially when I can't see all the cubes. So this is one way to do it. I'm actually going to take a screenshot of this so that we can use this later. But now I'm going to go back. And I want to go back to something I mentioned right at the beginning, which is, excuse me, that if we look at, remembering that this, we're going to call this the long way, we're going to say that this is length, L for length. If we go and we look at this, we're going to call this width, W for width. And if we think about the part that goes up and down, we're going to say that that is height, H for height. Oops. H for height. And I don't know if you remember when we talked about this in class, but we said that volume equals length times width times height. That is not a times symbol. That is length times width times height. So in this case, what was the length here? It was 1, 2, 3, 4. Length was not what I wanted. Length was 4. What about the width? 1, 2. Width was 2. And the height, it only goes up 1. Height of 1. So here we have 4 times 2 times 1. Let me extend this so you can tell that it's a 4. 4 times 2 times 1 is going to be 8. Here we have a length again of 4. We have a width again of 2. But this time we have a height also of 2, right? This up and down part. So here it's 4 times 2 for length and width. Length is 4, width is 2. But now the height times 2 again. So here we have 4 times 2 is 8, times another 2 is 16. You have a volume of 16. So I hope you're noticing that's something that we can do rather than count each individual cube or even count the layers in the cube, is look at how much across it is, look at how far back it goes, and look at how tall it is, and multiply each of those. So for this last one, we can go 1, 2, 3, 4, 5, 5 times width, 1, 2, times height, 1, 2, 3, 4. 5 times 2 is 10, times 4 is going to be 40. And if really quickly I actually pull up the screenshot we had just talked about, you'll notice that here I said the volume would be 8, my volume is 8. Here I said the volume would be 16, my volume is 16. And on this last one I said my volume would be 40, and I have a volume of 40. It matches up perfectly. So that is another way that we can think about calculating volume, and I do want you to start getting comfortable with this because it is going to help you as we start looking at structures that we can't count the individual cubes. All right. Bye, scholars. I will see you very soon, all right? And have a wonderful, wonderful day.